Hi guys, today we are going to study polygons, and I'm going to do a little mini series, 2 tutorials basically, and clearing concepts on angles, diagonals, etc. And then we will move into quadrilaterals. But before that, I thought that it's good to have a good generic understanding of polygons. So today we will learn about the types of polygons. We will learn about diagonals, what are convex and concave polygons, and then we'll learn about regular and irregular polygons. So let's start with polygons. What are polygons? Polygons basically are closed shapes, okay, with straight lines. They are polygons. So for example, this is a triangle, okay, it is a polygon. Similarly, uh, this is a rectangle, it's a quadrilateral. Yeah. Similarly, let's say this is a rhombus. This is also a polygon. Now, for example, do I have different kind of polygons? Yes, five-sided. Now this is a pentagon because there are 5 sides, so, and then there will be a hexagon as well with 6 sides. So I am just quickly looking for if I can draw a hexagon, and if I cannot, then what I will do is I will sort of forget about it. So something of this sort, that will be a hexagon. So basically these are polygons, they are closed figures, and they will have straight lines, and yeah, that's it. So triangle, quadrilateral, special case of quadrilateral, which is rectangle. This is also a quadrilateral because four sides. This is a pentagon because 5 sides. Hexagon, similarly, septagon, octagon, like that. So every polygon, basically it has diagonals, okay, it has sides and it has diagonals. So for example, I have a quadrilateral. The line segment that connects the two consecutive sides, let's say A and B are consecutive sides, they are sides. Similarly, the line segment which connects B and C, it is a side. The line segment that connects C and D, that's also a side. And the line segment which connects A and D is also a side. But whenever we join two non-consecutive points on a polygon, alright, so we will join A and D. So A and C, right? Because A and C are not consecutive. So AC will be a diagonal. Similarly, BD will be a diagonal. Okay. Now let's draw a pentagon. A, B, C, D, E, right? So AB, BC, CD, DE and EA, they are 5 sides of the pentagon. But AC, because now I am joining point A to point C, which are non-consecutive points. Similarly, I will join point B to point D because they are non-consecutive. Similarly, then I will join point C to point E, that is non-consecutive. All these are diagonals. Now the question is, depending on the number of the sides or depending on the polygon, how many diagonals are there? Okay, how many diagonals will be there? So let's first see. Let's start with here we see that there are 2. Okay. In triangle, tell me how many diagonals are there? In triangle, basically there will be 0 diagonals, right? Why? Because there are 3 points, and for every point the other 2 points will be consecutive on each side. In this side, let's say A, B, C are the 3 points. Then for point B, point A and point C both are consecutive points. Similarly, for point A, point B and point C are consecutive points, and for point C, point A and point B are consecutive points. Therefore, in a triangle you cannot have a diagonal, because the definition of the diagonal is that it is a line segment that connects non-consecutive points. Okay, so in a quadrilateral there are 2 diagonals, we drew it. In a pentagon, let's say A, B, C, D, E, Let's try and see how many diagonals can we draw. Let's start from point A and see how many can we draw. So we will first join C, that will be my first, then I will join D. E and B are consecutive, so I cannot. So with starting from point A, I have drawn all the diagonals that I could. Now let me change color and go to point B. Now from point B, the first diagonal which I will draw will go and join point D. The second which I will draw will go and join point T. Obviously, point A and C are consecutive. Now again, I will go to, so A is done, B is done. Let's come to C. Now from C, the first diagonal which I will draw will come to point E. Okay. The second diagonal which I will draw will come to point A, but I have already drawn that, right? So I have done C. From point D, the first diagonal which I will draw will connect point A, but I have already drawn it. The second one which I will draw will go and join point B, and that also I have already drawn. Same for point E, and same for point E as well, because EC and EB are already drawn. So how many diagonals are there? 1, 2, 3, 4, 5. 5 diagonals are there. Okay. Now let's try and see for a hexagon. Let's draw a hexagon here. Doesn't need to be a regular hexagon. Let's draw it. Let's start. Let's first name the points A, B, C, D, E, F. Now from point A I will join C. From point A I will join D. Okay, these three I have joined. Now from B I will join D. I will join E. I will join F. Then from C I will join E. I will join F. The moment I join A, I see that I have already drawn it. Again from D, I see that the first diagonal which I will do is I will join F. Then I will join A, but I have already done that. Then I will join B, I have already done that. Then I will join C, but then it's not a diagonal. Then I will come to point T, and then I will see that from point E, basically all the diagonals that I had, they already have been drawn. Similarly for point F. So there is a little bit of a technique, okay, when we move from the higher number of sides in terms of quadrilateral, then the number of diagonals will increase. And how it will increase, I want you to just focus on it, think about it. In my next tutorial or next to next one, I will cover the method of calculating the number of diagonals. But as of now, I want you to think about it. There is a trend to it. If you are able to just empirically draw and identify the trend and then put a formula, it is great. If you're not, I will make a separate 5-minute tutorial on this one. Okay. Then we'll come to convex and concave polygons. So let's say I am drawing a polygon like this, and I am drawing a polygon like this. Okay. A, B, C, D, E. Here also A, B, C, D, E. Right. Now this is a convex polygon. This one is a convex polygon. Now in a convex polygon, what happens is that whenever you join any 2 points, the line segment, irrespective of whether it is a side or a diagonal, it will always fall inside the region of the polygon itself. Whereas in a concave polygon, there could be cases where when you join 2 vertices, the line segment or some part of the line segment will fall outside. So in this, we see that the moment we join point E and C, this line segment is outside the region of the polygon. Therefore, these kind of polygons are known as concave, and these kind of polygons are known as convex. So that's the difference between concave and convex polygons. Regular, irregular, once again very simple. So for example, let me give you a good example. uh, I make a triangle, okay, in which all three sides are equal. Okay, this side is equal to this side is equal to this side. Then it is a regular triangle, right? If I make a square, right? If I make a square, all the four sides are equal. Similarly, if I make a pentagon, such that in such a fashion that all the five sides are equal, okay, that all the five sides are equal, in that case these kind of polygons, they are known as regular polygons. They are known as regular polygons. But if the sides are not equal to each other, let's say I make a scalene triangle, or I make an isosceles triangle, or I just make a rectangle for that matter, or just a quadrilateral like that, where the sides are not equal to each other, they are not equal to each other, or any polygon for that matter, such polygons, they are known as irregular polygons. So that was the first introductory sort of a sneak peek into polygons, and with that I am going to close this tutorial. I hope you enjoyed it. These are basic concepts, and first I will cover the basic concepts on polygons, and then we will move to quadrilaterals, and we will cover different kind of quadrilaterals one after the other. So I hope you enjoyed. Keep watching and share it with people that you feel might benefit from it.